Math with Oscar class. That's my dad.
When we talk about the surface area of a sphere, we apply the same principles we do for volume. The formula is just slightly different. Also want to be on the lookout for the fact that the hemisphere is a little more work to calculate when it comes time for surface area. Also be aware of hidden sides. So, if here we have a sphere of some known radius, the surface area is 4 pi r squared. It looks like the area of a general circle, or is referred to as a great circle in the case of a sphere, and there would be 4 of those total to encapsulate it, to surround it with surfaces. The derivation of this particular surface area is a little bit more intense, but like volume, if you look it up, you will find there's a rationale for the equation we use. It's not simply something that math teachers came up with because they thought it might work. A great deal of work went into deriving that particular equation. And again, a quick trip to Wikipedia as your first stop, but never your last, will show you that there is a rationale for this. Remember, Wikipedia. Stop one, but not stop end. CBS cares. Now, we can go ahead and let's take a look at a problem. For example, I want the surface area if the diameter is given as 76. And let's get some units on there, centimeters. Now, since the diameter is provided as 76, I have to boil that back down to get a radius. So I take half of that, I get a radius of 38 centimeters. Remember, radius, half diameter. Always watch diameter versus radius. It's the single most common mistake students make on these problems. Now, the surface area from there, 4 times pi times 38 squared. You simply plug and chug through the formula. Calculator time. Let's see here, 38 squared. And then I'd multiply that by 4. And again, I'm going to leave my answer in terms of pi because I don't want to mess around with decimals if I don't have to, and exact answers are just as acceptable as using 3.14 to get a decimal approximation. Notice my units are in square centimeters. They are not in terms of cubic centimeters. So even though it's a sphere, we are still looking for that surface area. I want to have an area set for my units. And really, that's kind of all there is to it. Our last example involving surface area is going to be one that mixes surface area and volume and a little backwards working. In this case, I'm told that the surface area of a given sphere is 324 pi square inches. I want the volume of that sphere. Again, because spheres only have one dimension to work with, it's very easy to work the problems both forward and backwards. Now, let's take that and actually get that radius. So I have some sphere out here in space that I'm talking about. I don't know the radius of that particular sphere, but I want to get it. I have the surface area though. So I know that 324 pi is going to equal 4 pi r squared. That's the formula of the surface area. The known surface area is provided. Plug it in, and I can then calculate what the radius must be. So 4 pi r squared. Now I can go ahead, let's get that radius from what's provided there. First I'm going to divide both sides by pi, and then divide both sides by 4, leaving me r squared on one side. On the other side, 324 divided by 4 gets me an answer of 81. Take the square root of each side, I get r is equal to 9 inches. So now I have a radius. With my known radius, I can go ahead and get a volume. Volume, we know, is 4/3 pi r cubed. Now that I have radius, I can plug it in, and I can then calculate out what the volume must be. With these problems, the key is not to go straight after what you want, it's to ask yourself, what can I find? Once you know what you can find, you can start doing the calculations to get an answer. I don't know how to go from surface area to volume, but I do know I can find the radius, bam, With the radius in hand, I can proceed on in order to get the volume. Let's go ahead and calculate that out now. I've got 9, which I'm going to cube. That gives me 729. Multiply that by 4/3. My final answer, 972 pi cubic inches. Again, I'm leaving pi in my answer because it just makes life a lot easier. I don't want to introduce turning that into a decimal if I don't have to. Find the radius first, and then use that in the formulas. For the most part, surface area volume problems really are a case plug and chug, or sub and solve, depending on whichever you like to say in alliteration versus a rhyme. Given the formula, surface area is 4 pi r squared, and volume is 4/3 pi r cubed. All right, good night and good luck.